In this video, I'll show you how to use differentiation to sketch the graph by using first and second derivative. For example, we have the function y equals 4/3x cubed subtract 4x. First, we are going to find the critical points by using first derivative. Y equals 4/3x cubed subtract 4x. To find the first derivative, dy dx equals to 4/3. So we have x cubed, so we get 3x squared, subtract 4. If we simplify this, dy dx, we have 4x squared subtract 4. To find the critical values, we let dy dx equals 0. It means that 4x squared subtract 4 equals 0. We factorize 4. We factorize 4 squared subtract 1. So we have x plus 1, x subtract 1 equals 0. So we have two critical values, x equals to -1 and x equals to 1. To find the critical points, we will substitute x equals to -1 into the original function. So if you substitute, you will get -1 over 3. You substitute 1 into this function as well, you will get 1 negative over 3. So you have two critical points here. To find the points of inflection, we will use second derivative. So our first derivative is actually 4x squared subtract 4. So our second derivative, when we differentiate first derivative, we get at x. To find the inflection point, we let second derivative equals 0. So we have x equals to 0 divided by 8, which is 0. So you can find the inflection point by substitute 0 into the y function. If we substitute 0 into the y function, we get 0, 0. So now we have two critical points and one inflection point. Next, we are going to use second derivative test to determine the nature of these critical points. Just now, we have second derivative equals to at x. If we substitute the critical value x equals to -1 into second derivative at x, we get a negative value, -8. So negative value for second derivative indicate that this point, -1 over 3, is actually a maximum point. So we will do exactly the same thing for x equals to 1. When we substitute x equals to 1 into the second derivative as well, at x, we get a +8. It actually indicates that the critical point 1 -8 over 3 is actually a minimum point. So now we have three important points: inflection point, maximum point, and a minimum point. Next, we are going to sketch the graph of y against x and label the coordinates of the critical points, which is 1 maximum, 1 minimum, and 1 inflection point. So we will label inflection point first at origin. So we have -1 and 1 here. At over 3, we just sketch 8 over 3 here and -8 over 3 here. So -1 over 3 is here, is a maximum point. 1 -8 over 3 is here, a minimum point. So we will just sketch the graph accordingly. So we have the maximum point here -1 at over 3, inflection at origin, and a minimum point at 1, -L over 3. So we have used the differentiation method to sketch the graph.